Hello and welcome. This is cross-validation to optimize the performance of machine learning model. In this tutorial, I will dive into the powerful technique known as cross-validation and its crucial role in assessing the performance of machine learning. At its core, cross-validation is a robust validation technique that used to evaluate how well a predictive model will perform on unknown or unseen data. It achieves this by partitioning the available dataset into complementary subsets, one for training the model and the other for testing its performance. By iteratively rotating these partitions, cross-validation provides more reliable estimates of how the model is likely to generalize previously unseen data. Why is cross-validation so important? And you may wonder, well, traditional evaluation methods such as training a model on one set of data and testing it on another way may not fully represent the model's true performance. That's why cross-validation mitigates this issue by maximizing the use of available data for both training and validation, and providing a more accurate picture of a model's ability to generalize to unknown or unseen data. This is particularly crucial when dealing with limited datasets or when striving for a robust and reliable predictive models. So join me as I explore the intricacies of cross-validation and understand how it plays a pivotal role in the evaluation of machine learning models. Here are the steps to implement cross-validation. The first step is import required libraries. Here you have to import NumPy, Pandas, Matplotlib to visualize the result or accuracy. And IP widget is one of the Jupyter Notebook built-in library that help us to interact our graph or visualization, especially if you want to implement slide. And the other is cross-validation. You can import the module cross-validation from scikit-learn model selection module. And maybe logistic regression. In this case, I'm going to implement logistic regression, but you can implement any one of the classification algorithm. And you can also import the train test splits from scikit-learn model selection module, standard scalar that help us to pre-process and scale the data values. And once you import the necessary, you can then read the customer churn data. I have the customer churn data, as you can see here. So all the data contains values, and the values are in numbers right now because this is already encoded into numerical values in the previous tutorial. You can watch previous tutorials about encoding the categorical values into numeric values. And then separate the target variable and futures. Here, the churn column is a target variable, so you have to separate the futures variable as X and the target variable as Y. So you can draw custom rate and churn to get the future variables, and you can also get the target variable. Okay, the next is splitting the data set into training and test set. That's very important. You can use train test split, and here I have split the data set into 15% is test data set and 85% is the training data. Then you can scale the values of using standard scalar. That is very important because, as you can see here, the values are not in standard scalar, so you have to scale in the minimum and maximum values of the futures by using standard scalar class. Okay, you can transform into the standard, especially the X train and X test. And the next step is choosing the appropriate or the type of cross-validation. Basically, there are three commonly used cross-validation types, and some of the common types of cross-validation are the k-fold cross-validation. This is the most commonly used cross-validation, and stratified k-fold cross-validation, and leave one out cross-validation. And there are other cross-validations, but here I'm gonna show you using k-fold cross-validation. The k-fold cross-validation involves dividing the dataset into k subsets of equal sizes. So this is one of the most commonly used cross-validation, that's dividing the dataset into k subsets of equal size. Each data point or datasets has equal size. It's divided into k subsets. The model is trained on the k minus 1 subsets and tested on the remaining subsets. So once the dataset is divided into k subsets of equal size, and it's just train the model on the k minus 1 subsets and test on the remaining subsets. This process is repeated k times, k number of times or fold, each time using a different subset as a test set. So the final performance metric is often the average of the individual performance across all k iterations. You just iterate over k iterations. Now, going to create a logistic regression models and cross-validation, and pass the model to the cross-val score function and pass the X train and Y train. Here are the CV parameters. This is cross-validation parameter, and you can pass the number of iterations here, 5, and scoring is accuracy that evaluate the model performance. And then you can print out the CV scores or cross-validation scores and the average of the cross-validation. Here, the model that perform in each iteration. So we have 5 cross-validations or k-folders. So the training data can be divided into 5 equal sizes and test the training on k minus 1. And here the average cross-validation score. So you can see that the scores on each fold, each iteration, and finally it's just find the average of the 5 folds of the cross-validation score. So the average is 57%. In this example, the cross-val score applies 5-fold cross-validation on your data using the logistic regression model, and the CV parameter specifies the number of folds, and scoring accuracy indicates that the accuracy metric is used to evaluate the model. You can adjust the parameters and the scoring metrics based on your specific requirements data. We can create an interactive slider to choose the best performing cross-validation. So you can define a function to perform cross-validation with a variable number of folds. You can specify here the logistic regression and X train, Y train, and you can pass the CV parameter and number of folds here when you are sliding the slider, and you can find the optimal number of folds. So scoring is accuracy, and you can print cross-validation score, CV score, and average cross-validation score in this case. Then you can visualize using math plot, and range starts from 1 up to the total number of the selected k folds scores plus 1. And here the CV scores, the marker is line ... and color is blue. You can choose any color. Then cross-validation scores for dataset, number of folds, and mean score validation, the Y label, and the X is the number of folds. So this title is cross-validation scores, and you can see the grid is true, and finally plot. And you can create an interactive slider to select the number of folds. Here starting point is 2 and ending is 10, and stepwise 1 by 1. So it's just add 1 in each starting point and up to 10. So let me run this code and see the cross-validation graph. So initially it is 6. The 6 cross-validation, the number of folds is 6, and you can see the mean cross-validation score at each number of fold. So if it is 1, it is around this cross-validation. It is 2, around 50. It's 3, around greater than 60. And 4 is the lowest cross-validation. So it is not optimum if you choose 4. And 5 is this one, and 6 is the last iteration. The last iteration is 6. So at 6, the total or the average cross-validation score is 53. So you can see each scores in each iterations of the folders. So we have 6 folders. When you are putting sliding the slider to 5, you can see that it is 57%. So at fold or at iteration 4 is the highest one. It is greater than 62% of accuracy. But in the range of 1, 2, and 3 are the lowest accuracy. It is less than 57. It is greater than 56. So the average cross-validation score is 57 in this case. So as you can see, 5 is best performing cross-validation. So you can choose the number of fold is 5 while training the model. When you are sliding this to 7, 8, for example, 8 is 53, 9 is 53, and 10 is the lowest. It is around 51. So that is 5 is, so you can choose by building such kind of cross-validation visualization to find the best or the optimal K folders or number of folders by sliding this visualization, interactive visualization. So, 5 is the best according to this result. So you can use 5 number of folders or cross-validation value, and you can train the models based on that. So I hope you enjoyed this video tutorial. Don't forget to like, share, and subscribe. Thanks for watching.